This section is about fluid mechanics, and a fluid is a liquid or a gas. So it could be a liquid such as water, or it could be a gas such as helium or air. What makes liquids and gases fluids is that they take the shape of their containers. When we classify solids, liquids, or gases, we talk about their volume and their shape. And so a solid has both a definite volume and a definite shape. Volume doesn't change, nor does the shape change if you move it from one spot to another. For a liquid, we say that its shape can change, but its volume does not if we move it from container to container. And for a gas, both the volume and the shape will change as we move it to a new container. In both the liquid and the gas, it's the shape that can change. So if it changes shape, it's got to be a fluid. First topic under discussion under fluid mechanics is going to be density. Now there's many different types of density. There's population density, there's charge density. We're talking about mass density, but we're just going to say density just to make things simple. I think we all know what we're talking about if we just use the term density for this section. Density is defined as mass per unit volume. What that means is that if I have a density of gold, which is 19.3 grams per milliliter, that means for every milliliter I have of gold, it has a mass of 19.3 grams. So if I have 1 milliliter, it will be 19.3 grams. If I have 2 milliliters, it's going to be 38.6 grams, and so forth and so on. But what is that really representing about this substance? So if I have a substance like gold, which is 19.3 grams per milliliter, versus a substance like 2.7 grams per milliliter for aluminum, that means if I have the same amount of gold as I do aluminum, let's say I have 1 milliliter each, it means that I'll have 19.3 grams of gold, but only 2.7 grams of aluminum. So there must be more stuff packed into the gold. In other words, there's more atoms packed in there. The atoms are closer together. So we're going to have a higher density based on the closeness of the atoms. Density is mass per unit volume, so our equation is mass divided by volume. And our symbol for density is the Greek letter rho. So if I draw it freehand, it kind of looks like a combination between a P and an E, lowercase e, and a lowercase p. Mass over volume, which means that our units, now you're probably used to units of grams per milliliter, but in physics here we're talking about things like newtons, which is an abbreviation of a kilogram times meter per second squared. And so we're going to have our mass in kilograms and our volume in cubic meters. Now the conversion from grams per milliliters to kilograms per cubic meter is that for every 1 gram per milliliter, there are 1,000 kilograms per cubic meter. So when we talked about the density of gold, which is 19.3 grams per milliliter, there's an easy conversion. That is just 19,300 kilograms per cubic meter. Now, all of this is related to when we talk about density. Usually we talk about things floating or sinking. Objects will float if the object is less dense than the fluid, and an object will sink if the object is more dense than the fluid. So if I have my substance, like let's say aluminum. Aluminum is 2,700 kilograms per cubic meter. Aluminum is going to float or sink in water because water's density is 1,000 kilograms per cubic meter. It is more dense than water. However, if we look at liquid mercury, mercury has a density of 13,500 kilograms per cubic meter. And so aluminum will float in that mercury because it is less dense than that